Welcome to the deep dive.
Oh.
We're diving into the history of artificial intelligence today.
Oh, cool.
Yeah, we've got these excerpts from a text file
Okay.
called Artificial Intelligence, the Essential for Curious People.
Right.
And it's really fascinating stuff.
I bet.
You know, it turns out that people have been fascinated by the idea of creating thinking machines for like forever.
Yeah.
Way longer than I would have thought. It goes like way back, even further back than sliced bread.
Wow. That's
I know, right? We're talking ancient myths, early automatons, the whole shebang.
It's amazing how these early ideas about artificial beings really foreshadow, like our modern day pursuit of AI.
It's true.
It makes you wonder if like this desire to create, to understand, maybe even to replicate ourselves, if it's just something deeply ingrained in our nature.
It's like we're looking in a mirror from the
Yeah.
past. Speaking of mirrors, have you ever heard of Talos?
Talos.
Yeah, he was this giant bronze automaton in Greek mythology.
Oh, okay.
And his job was to guard the island of Crete.
Okay.
Talk about an early security system, right?
Yeah, Talos is like a perfect example of how our ancestors explored this whole concept of artificial life,
Right.
through stories and myths.
Yeah.
But that desire to create these artificial beings,
Yeah.
it wasn't just confined to mythology or anything like that.
No.
We see it popping up throughout history, all these different cultures.
Yeah.
I mean, take Paracelsus, for example.
Paracelsus.
He was a 16th century alchemist
Oh, wow.
who actually believed that he could create an artificial man using this this concoction of, well, let's just say some pretty unusual ingredients.
Okay, so horse dung and the arcanum of the blood of man aside.
Right.
What I find so fascinating is the why,
The why.
Yeah, like why was Paracelsus so obsessed with this idea?
Yeah.
And why are we still grappling with these questions
Right.
about creating life even today with AI?
Right. I think it speaks to just this fundamental human drive,
Yeah.
to understand the mysteries of life.
Yeah.
To push the boundaries of what's possible.
Okay.
And maybe even to transcend our own limitations in a way.
I can see that.
We see this reflected in all those intricate automatons
Yeah.
created by these skilled artisans throughout history.
Oh, yeah, like those clocks with the little moving figures.
Right, exactly.
Or those mechanical toys that could like write or draw.
Unbelievable.
I know, it's crazy.
It's like they were trying to breathe life into metal and gears.
Yeah, it really makes you wonder what those inventors would think of today's AI.
I think they'd be absolutely blown away, truly.
I think so, too.
But I also think they might recognize a familiar spark,
Oh, interesting.
That same drive to create, to innovate,
Yeah.
to explore like the very essence of intelligence.
So we've established that humans have been dreaming of AI for centuries.
That's definitely.
But when did those dreams start to, like, take a more concrete form, a more scientific form?
Well, you might be surprised to learn that the foundation for AI was actually laid with some pretty familiar names,
Okay.
Philosophers like Aristotle and Euclid.
Wait a minute. You're saying that my geometry teacher was unknowingly prepping me for the world of artificial intelligence?
Exactly.
Wow.
They developed those structured methods of reasoning,
Yes.
like, syllogisms
Right.
and geometric proofs, what we all struggled with
Oh, yeah.
in school, right?
Yeah.
Those logical frameworks became essential building blocks for AI centuries later.
Huh.
But the official birth of AI as a field,
Okay.
it's widely considered to be the Dartmouth Workshop in 1956.
The Dartmouth Workshop.
Yeah, this is where a group of like brilliant researchers came together
Oh, wow.
to formally define the field and set the stage for decades of research to come.
So what exactly happened at this Dartmouth Workshop? Did they like have this eureka moment and just like crack the code to creating thinking machines?
Not quite.
Okay.
But there was a real sense of optimism and excitement in the air.
I bet.
The early AI programs of the 1950s and 60s,
Yeah.
they were achieving things that seemed almost magical at the time.
Really?
I mean, computers were solving these complex math problems,
Okay.
proving theorems,
Wow.
even starting to understand human language a little bit.
Yeah.
It felt like we were on the verge of creating something truly extraordinary.
So everyone just thought like super intelligent robots were just around the corner.
There was definitely a lot of hype.
Yeah.
And some pretty bold predictions being thrown around. But as with any new field, there were challenges and setbacks along the way.
Can imagine.
And that leads us to a period known as the AI winter.
The AI winter.
Which really tested the field's resilience and forced researchers to reassess their approach.
Okay.
But before we get into that, let's talk about one of the most iconic early AI programs.
Okay. Eliza.
Yeah. So Eliza was this chatbot created back in the 1960s.
Okay.
And get this, it actually convinced some people they were talking to a real therapist.
Oh, wow.
It's this phenomenon that's now known as the Eliza effect.
Wait, so people were like pouring their hearts out to a computer program?
It happened, yeah.
I guess that just shows you the power of language, right?
It really does.
Even if it's just cleverly programmed code.
Right.
But this Eliza thing, was it really intelligent? Or was it more like a parlor trick?
That's a great question, and it really gets at like the heart of what we even consider intelligence, right?
Yeah.
Eliza was very good at mimicking human conversation.
Okay.
But it wasn't truly like understanding the meaning behind the words.
Right.
It was more like following a set of rules and patterns.
There's more smoke and mirrors than genuine understanding.
I think that's a fair assessment.
But even if it wasn't really thinking, you know, like it in the human sense, I mean, Eliza must have given researchers some valuable insights.
Oh, absolutely.
Yeah.
Eliza and other early AI programs, they really highlighted the complexity of what we were trying to achieve, you know? Like, it wasn't just about like crunching numbers or solving logic puzzles to truly replicate human intelligence.
Yeah.
We needed to grapple with things like common sense reasoning, understanding context, and learning from experience.
So it sounds like researchers were starting to realize that AI was a much tougher nut to crack than they initially thought.
Exactly. And that realization, coupled with some of the technical limitations of the time, led to a period of, well, disillusionment, you might call it.
Okay.
It's known as the AI winter.
The AI winter.
Yeah, funding for AI research dried up.
Really?
And the field went through a bit of a slump, I guess you could say.
So it was like a reality check for the AI community.
I think so, yeah.
But did everything just like grind to a halt during this AI winter?
Not at all. Even with, the reduced funding, research continued.
Okay.
And there were some important breakthroughs in areas like logic programming and knowledge representation.
So it was more like a regrouping and refining period.
Yeah, I think that's a good way to put it.
Okay.
A time to step back and rethink the approach.
And that's exactly what happened.
That's exactly what happened. In the 1980s, AI experiences this resurgence with the rise of expert systems.
Expert systems.
Yeah. So instead of trying to create, this general purpose thinking machine, researchers focused on developing programs that could solve very specific problems using specialized knowledge, almost like having like a digital expert on call.
So like a more practical, targeted approach. Kind of like saying, okay, we can't build a robot that can do everything.
Right.
But we can build one that's really good at like diagnosing diseases or playing chess or something like that.
That's a great analogy, yeah. Okay. Expert systems were a big hit. And they really sparked this renewed interest in AI. Companies and governments around the world started investing in AI research again.
Do you remember the Japanese 5th generation computer project?
Oh, yeah. How could I forget?
That was such an ambitious attempt.
It really was.
To build a computer that could reason like a human.
I know. It was a massive undertaking.
And it ultimately fell short of its goals, right?
It did, unfortunately. But it did contribute to some important advancements in areas like parallel processing and logic programming. So
it wasn't a total loss.
Not at all, no.
And while expert systems were taking off, there was another exciting development happening kind of in the background.
Oh, yeah.
A revival of interest in what was it called?
Connectionism.
Connectionism, right? Remind me what that is again?
So connectionism, it's the idea of modeling artificial intelligence on the structure and function of the human brain.
Okay.
Remember those neural networks we talked about earlier?
Yeah, I think so.
Well, connectionism basically brought them back into the spotlight.
Okay.
Researchers started making these breakthroughs in understanding how neural networks could learn and process information in a way that was much more similar to how our brains work.
So instead of programming computers with like rules and logic.
Right.
They were trying to get them to learn from experience like we do.
Exactly.
Interesting.
And the shift in thinking combined with, some really incredible technological advancements paved the way for what we now call the deep learning revolution.
Deep learning, that's the AI that's like everywhere these days.
It's true. It's really taken off.
But what exactly makes it so revolutionary? Like, how did we go from those early neural networks to the AI that's, powering self-driving cars and generating those photorealistic images?
It's a fascinating story, and it all kind of boils down to a convergence of factors.
Okay.
We're talking about a perfect storm of advancements in computing power.
Okay.
The availability of just massive data sets.
Okay.
And some honestly ingenious innovations in neural network architecture.
Okay, so break that down for me a little bit.
Sure.
What were these like game-changing advancements?
Okay, so first you have computing power, which just skyrocketed.
Okay.
I mean, think about how much more powerful your smartphone is today.
Yeah.
Compared to the computers that were used to land a man on the moon.
It's crazy.
That same like exponential increase in computing power has been a driving force behind deep learning.
Okay, so more computing power, then you have the explosion of data.
Right, exactly. Billions of images, text documents, audio files, you name it.
Okay, so more computing power and tons of data.
Right.
Got it.
But you also mentioned ingenious innovations in neural network architecture, remember?
I do. What does that even mean?
Okay, imagine a neural network as a multi-layered cake.
Okay, a cake.
With each layer processing information and passing it on to the next.
Okay.
The more layers you add, the deeper the network becomes.
Okay.
And the more complex patterns it can learn.
Yeah.
It's kind of like adding floors to a skyscraper to accommodate more workers and more specialized departments.
So more layers, more brain power.
Basically, yes.
Okay, I'm starting to get the picture.
These deeper networks, combined with those advancements in computing and data, allowed AI to tackle problems that were previously considered impossible.
Wow.
Image recognition, speech recognition, natural language processing, all these fields,
Yeah.
they were completely transformed by deep learning.
So when I ask my smart speaker to play my favorite song or use an app to translate a sign in a foreign language, that's deep learning at work.
Precisely.
Wow.
And the applications go way beyond that. I mean, deep learning is powering virtual assistants, personalized recommendations, medical diagnoses, financial forecasting, even self-driving cars.
It's amazing.
It's truly revolutionized the way we interact with technology and with the world around us.
It sounds like deep learning has just opened up this whole new universe of possibilities.
It really has.
But with all of this incredible power, it also raises some important questions, right?
Oh, absolutely.
I mean, like, what happens when AI becomes so advanced that it starts to challenge our understanding of what it means to be human?
You've hit on a really crucial point as AI continues to evolve, and it's happening at this unprecedented pace.
Right.
We're entering like uncharted territory here.
Yeah.
And it's forcing us to grapple with some really profound questions about the very nature of intelligence, consciousness, and our own humanity.
It's almost like we're catching a glimpse into the future. And it's both, like exhilarating and a little bit unnerving, you know?
I know what you mean.
We've created these machines in our own image.
Right.
But what happens when they start to surpass us?
Right.
In ways we can't even imagine.
Yeah.
It's the stuff of science fiction. But it feels like science fiction is becoming reality faster than ever before.
It's a sentiment shared by many, that's for sure.
Yeah.
The rapid pace of AI development, it's raising all these questions that were once, relegated to the realm of philosophy and speculation. But now they're demanding our attention, urging us to really consider the potential consequences of creating something that could, like, fundamentally reshape our world and our very understanding of what it means to be human.
So where do we even begin to unpack all of this? Well, I mean, we've talked about the history of AI, the breakthroughs in deep learning, and now we're facing this like almost existential crisis.
I know.
A lot to process.
You're right. It is a lot to process. And there's no like easy answer, There's no single roadmap to navigate this uncharted territory. It's new for all of us.
Yeah.
So maybe one way to approach it is by looking at the questions that AI is forcing us to ask.
Yeah.
Questions about the nature of intelligence, consciousness, and even, the future of our species.
Okay, let's start with the big one.
Okay.
Can machines truly think? I mean, we've already talked about Eliza,
right?
Tricking people into thinking they were talking to a real therapist.
Yeah.
And deep learning is doing some pretty mind-blowing things these days.
It is.
So are we on the verge of creating machines that can actually think for themselves?
That question of machine consciousness, it's a long-standing debate.
Yeah.
There's no easy answer.
Right.
One way to think about it
Okay.
is through the lens of the Turing test.
The Turing test.
Yeah, it proposes that if a machine can engage in a conversation that's indistinguishable from a human's, then it could be considered intelligent.
Okay, but couldn't a really sophisticated program just be simulating conversation?
Right.
Without actually understanding what it's saying?
Right.
How do we differentiate between, genuine intelligence and just clever programming?
That's the crux of the argument.
Yeah.
And it leads us to another thought experiment.
Okay.
Called the Chinese room.
The Chinese room.
Okay. Imagine a person who doesn't speak Chinese, locked in a room with a set of rules for manipulating Chinese symbols.
Okay.
People outside the room, they slip in these questions written in Chinese.
Okay.
And the person inside, using the rule book, they can formulate answers that are grammatically correct.
Okay.
Even though they have no understanding of the meaning.
It's just like using a phrase book.
Right, exactly.
To get by in a foreign country.
Yeah.
Without actually speaking the language.
Right.
You can communicate on a basic level.
Yeah.
But you're not really understanding the nuances.
Exactly.
And the complexities of the conversation.
The Chinese room argument basically suggests that even if a machine can process information and generate these seemingly intelligent responses, it might not necessarily be experiencing true understanding or consciousness.
Okay.
It raises the question of whether simply manipulating symbols actually equates to genuine thought.
So are we just chasing a technological illusion then? Is true artificial intelligence the kind we see in science fiction movies just a pipe dream?
It's a question that continues to spark debate and fuel research.
I can imagine.
And while we may not have, definitive answers yet, the pursuit of AI, it's really pushing us to delve deeper into the mysteries of the human mind and explore the very essence of what it means to be, intelligent, conscious beings.
It's fascinating.
It is.
And a little bit intimidating, I have to admit.
I understand.
To think about all the potential implications.
Yeah.
I mean, if we do manage to create these machines that can think for themselves, what does that mean for humanity?
Right.
Will we be partners or rivals? Will AI be our greatest invention or our biggest mistake?
Those are the questions we need to be asking ourselves right now as we stand on the cusp of this technological revolution. AI has the potential to transform our world in ways we can barely fathom.
It's true.
And it's our responsibility to ensure that this transformation is a positive one.
Well, I think it's safe to say that our deep dive into AI
Yeah.
has left us with more questions than answers.
It always does, doesn't it?
But I think that's the beauty of exploration, isn't it?
I think so.
It's about embracing the unknown and pushing the boundaries of our understanding.
Absolutely.
Well, thank you for joining us on this deep dive
Of course.
into the fascinating world of artificial intelligence.
It's been a pleasure.
It's a world that's full of challenges and opportunities.
Definitely.
And it's one that will continue to shape our lives in profound ways for generations to come.